based on the duality principle. The first problem is duality principle. So under duality principle, we know about plus is converted to dot, and dot is converted to plus, or 1 is converted to 0, 0 is converted to 1, right? As per the duality principle.
Yes, sir.
Yeah, under the first problem is, for example, find the duality of for the following function. The function is ab c bar plus,
Sir, screen is not visible, sir.
sorry ma, thank you. Now it's okay ma.
Yes, sir.
Yeah. So now we were calculating the duality of this function. So ABC bar plus A bar BC plus ABC. So what is the duality of this one? So simply, so by using these four things, we are converted into duality expression. So based on these things, so we are converted into A plus B plus C bar into A bar plus B plus C into A plus B plus C. So this one is the duality of given expression. Is it okay?
Yes, sir.
Yeah. Then find the duality. Find the duality of AB plus BC plus CA. So what is the duality of this expression?
A plus B into B plus C into C plus A.
Yeah, A plus B into B plus C into C plus A. Then again, if you are finding again duality function,
We get F, sir.
we get F only. AB plus BC plus CA. So this type of expression is called as self-dual. Okay.
Yes,
So
sir.
if the question consists of like this, so find the self-dual of following expression. Find the self-dual of following expression. So self-dual in the sense of we are getting same answer only. So first we are taking one duality function, and then again we are applying duality of the function. So we are getting self-dual. Otherwise, so simply the given equation is nothing but self-dual function. Okay.
Yes, sir.
Yeah. Please take a note. Uh, if in some of the logical expressions, in some of the logical expressions, is not all dual functions. So some expressions. So for example, if I'm getting a, so if I'm taking a, so f equal to a, what is the duality of this one? What is the duality of this one?
A bar.
Sorry, a only. So here we are not interchanging that a with a bar or b with b bar. So simply we are taking same numbers, so same variables. So instead of taking dot, here we are using plus. So if we are taking plus, so here we are using dot. So here a plus b plus c bar, right? We are not interchanging the variables. So A is similar to A only, B is similar to B only, C is similar to C bar. Sorry, C bar is similar to C bar. Here we are interchanging dot with plus and plus with dot. So that's why I said that. So in sometimes, so some logical expressions. So we are not taking the duality functions. For example, so if we are taking the expression will be F equal to A. So what is the duality of this one? A only, right?
Yes, sir.
So this is also very important question. So please don't take the inverter of this form. So if you are taking duality of function, so please don't take the inverter. So simply we are using plus with dot and dot with plus. Okay.
Yes, sir.
It consists of three parts. So if you are using AND gate, so here, so this one is AND gate, right? ABC is nothing but ABC bar. For getting ABC bar, we are using AND gate, right?
Yes, sir.
Yeah, and is replaced with here, and is replaced with OR gate.
Or
Yeah, R is replaced with AND gate.
and get
Yeah, AND gate. Dot is replaced with plus, and
plus and plus
plus is replaced
replaced with
with
dot.
dot. And what about variables? And what about variables? Keep
They are same.
keep variable as it is. Keep variables as it is. So this one, A, B, C bar are the variables. So please keep this variables as it is. Okay.
Yes, sir.
Yeah, so this is very very important thing. And also, if you are using n variables, so for example, the expression, for example, an expression consists of a, b, c, and so on, some number like n variables plus a bar, b bar, c bar, and so on, n variables. So like this. So at that time we are taking duality function. Okay, at the time also we are taking duality function. So that n variable duality function can be defined as 2 power n minus 1. Is it okay, ma?
Yes, sir.
So simply, if I'm taking self dual of n variable function, so if I'm taking self dual of n variable function, at the time we are using this formula. So if I'm using one variable, so if n is equal to 1, what is the value? 2 power 1 minus 1. So 2 power 1 minus 1 in the sense of
2.
2 power 0. So 2 power 1, that is nothing but 2. So if you are using variable a, so it will be changed to a only, otherwise a bar will be changed to a bar only. So these two values are formed. Is it okay, ma? So
Yes, sir.
if I taking a, so what is the duality of a
A only.
for a bar?
A bar.
Yeah, so these two are formed. So if you are using n equal to 2, so if n equal to 2, so what we are getting?
4.
2 power 2 minus 1. So 2 power 1. So simply 4. So what are they? So a becomes a only, a bar becomes a bar only, b becomes b, and b bar becomes b bar. So these four are the possibilities. Is it okay?
Yes, sir.
Yeah, if you are using n equal to 3, so what is the value we are getting? So 2 power 4. 2 power 4 or 2 power 3?
16.
Yeah, 16. 16 possibilities are there. So what are so what are they? So here a is nothing but a bar, and b, sorry, a is nothing but and a bar is nothing but a bar, b bar is nothing but b bar, b is nothing but b, c is nothing but c, and c is nothing but c bar. So and then similarly a bar, b bar plus b bar, c bar plus c bar, a bar, and it is also ab plus bc plus ca. So like this we are getting 16 terms. Okay.
Yes, sir.
Yeah, now the question is complement question. So now we are finding complement of the function. So if we are using the function y is equal to abc plus a bar bc plus a b bar c. So what is the complement of this function? Yeah, complement of this function. So simply we are taking y bar now. So y bar is nothing but, so we are applying entire bar. So this is nothing but abc bar dot a bar bc dot a b bar c whole bar. So it is in the form of a bar plus b bar plus c. So here we are using De Morgan's theorem. So it becomes a plus b bar plus c, and it becomes a bar plus b plus c bar. So this one is the complement of the function. So simply y bar. Okay, ma? So for
Yes,
complement
sir.
also, so we are using, so and is replaced with in a complement function, and is replaced with r,
R
or dot is replaced with plus,
plus
the plus is replaced with dot,
dot.
and complement of each variable. Yeah, complement of each variable. So these are complement for duality principle, nana, and is replaced with r, dot is
And
replaced
dot
with
is
plus,
replaced with plus.
plus is replaced with dot, and keep as it is, right?
Yes, sir.
Variables keep variables as it is. So this is nothing but dual. So are you getting the differences between complement and duality principle? Yeah, in
In
complement the variable
complement, the variable.
also complemented. In duality, variables are constant, so we are not changing. Okay.
Yes, sir.
Yeah, then we are going to another problem. So the problem belongs to Venn diagrams. The problem belongs to Venn diagrams. Venn diagrams. Yeah. So if you are using two variables, so how many possibilities are there, Nana? How many possibilities are there?
4.
Yeah. So that they are A bar, B bar, comma, A bar, B, comma, A, B bar, and A, B, right?
Yes, sir.
Yeah. For these, we are representing a Venn diagram. So that Venn diagram can be like this. So if you are taking this one as A, so this one as A, and this one as B. So for this, we are using one set, right? Yeah. So A bar, B bar in the sense of what is the value, Nana? So by using binary values, A bar is nothing but 0, B bar is nothing but 0.
Okay.
So that's why this entire part, this red line part is nothing but A bar, B bar. Here we are not taking any value. Okay.
Yes, sir.
Then coming to this one, Nana. So this one. So it is nothing but A, B bar. So what is the maximum value here for this one? So here the maximum value is A. That's why it is nothing but A, B bar. And for black line, it is nothing but A bar B. Okay. And this shaded part, this shaded part is nothing but AB. So the shaded part is nothing but AB. So based on this one, so based on this Venn diagram, we are getting some problems. So if the problem consists of like this, so what is the Boolean expression we are getting here? So simply the shaded part will be the Boolean expression, right? So if we are getting question will be like this. So what is the Boolean expression we are getting? So here the
A
shaded,
bar, B bar,
yeah, A bar, B bar plus,
A, B bar plus A, B.
yeah, A, B. So this one is the expression for this Venn diagram, okay?
Yes, sir.
Yeah, so then similarly, if you're taking like this, what is the expression here we are getting?
AB bar plus A bar, B bar. A bar, B.
Yeah, AB bar, AB plus, AB bar plus, AB bar, right? Yeah, these three terms we are getting, right? So these three terms are the shaded terms here. AB plus A bar B plus AB bar. Is it okay, ma?
Yes, sir.
Yeah. So similarly, the question will be like this. So if you are getting question will be like this. So at that time we are getting expression called as. So here we are taking all the terms, right?
Yes, sir.
A bar B bar plus AB plus
AB
A
plus
bar B
A bar
plus
B plus
B bar.
A B bar.
By using so this type of Venn diagram also we are getting the exact result. Similar if you are using three variables. So if you are using three variables, so if you are using three variables, you will be like this. Yeah. Sorry. This one is A, this one is C, and this one is A, and this one is B. Yeah, for first one, what is the value of this one? First box, first round,
A B bar C bar.
A B bar.
C bar.
Okay. So this one is nothing but A B bar.
C bar C bar.
What about second one, Nana?
A bar B C bar, sir.
A bar B C bar. So what about last one, ma?
A bar B bar B bar C.
Yeah, super. Then coming to this one, so if I are getting this shaded part, so if I are using like this shaded part,
A B C.
wait a minute. Yeah, so this one is nothing but ABC
A
bar,
B
right?
C.
Yeah, ABC bar, ma. So this one, Nana. So this one. So we are not including C, right? So we are not taking blue line.
Yes, sir.
Yeah, so if I are taking this one, so if I are taking like this, so what is the value here we are getting? ACB bar, right?
Yes, sir.
Yeah, simply A B bar C. For this, Nana. So if I taking like
A
this,
bar C B.
so this one is nothing but A bar C B. Okay. Then last one, Amma. So if I taking like this, yeah, this one. So this portion is nothing but ABC, right?
Yes, sir.
Yeah. So how many terms here we are getting? Seven terms, right? One, two, three, four, five, six, seven, right?
Yes, sir.
Yeah. What about last term, Nana? So it
A
is
bar B bar C bar.
yeah, A bar, B bar, C bar. Super. So if the question will be like this, yeah. So what is the answer for this one? So you are taking how many terms? Four terms or eight terms?
4.
Yeah, four terms. So one thing is
A
ABC,
B C bar.
ABC,
Okay.
ABC bar
Plus
plus
A
A
bar
bar
C B
BC, A
plus
bar
A
BC
B bar
plus
C.
A
B bar C.
B bar C. So but for this, what is the reduced expression? For this, what is the reduced expression here? So if I'm taking
A
AB,
B
AB into C
C
plus
plus
C
C
bar
bar
plus A bar B plus A B bar into C.
C.
So that is equal to,
A B plus A XOR B into C.
yeah, so this one is the reduced expression, right?
Yes, sir.
Yeah. Uh, so by using this Venn diagram also, we are getting some lot of problems. So is it okay, Ma? Is it clear by using the Venn diagrams how to get the Boolean expressions?
Yes, sir.
Yeah, okay, super. Then we are moving to next one. So find the mean function. So next question: if are a logical logic circuit have three inputs, they are A comma B and C, and the output F is equal to 1 when majority number of inputs are when majority number of inputs are logic 1. So this one is the question. So for this question, how many inputs are there?
3.
Yeah, three inputs. So they are A, B, C. So if you are using three variables, so how many possibilities are there, Nana?
8, sir.
Yeah, eight variables. So the eight variables are 0, 0, 0, 0, 0, 1, 0,
0,
1, 0, 0, 1,
0, 1,
1,
1.
1, double 0, 1, 0, 1, 1, 1, 0, triple 1. Then it consists of only one output, right? F.
Yes, sir.
Yeah, so here one condition is there. If f equal to 1, so on the output f equal to 1, when majority when majority number of inputs when majority inputs when majority of inputs are when majority of inputs are logic 1. So the meaning is that, so if it consists of three inputs, right? A, B, C. So whenever we are getting more than one, so that is the function of this one. So here, how many ones are there for 0, 0, 0? So there is no ones, right?
Yes, sir.
So that's why we are putting 0. And in cases of 1 only, so 0, 0, 1. How many ones are there for the 0, 0, 1?
1.
Yeah, so majority of ones are there or majority of zeros are there for these three?
Majority of zeros, sir.
So majority of zeros there. So that's why I'm putting 0 here. And coming to this one, so here also majority of zeros are there. So that's why here also we are putting 0. And
0,
this one,
1,
yeah, 0, 1,
1. 0,
0, 1,
1,
1,
1, and
1.
1. 1.
Yeah. So for this, so we are getting four ones, right?
Yes, sir.
Yeah, one, two, three, four. So this F is belongs to this one. So this one is nothing but A bar
3.
BC, right? A bar BC, right? Is it okay, ma? A bar BC? A bar
Yes,
is
sir.
nothing
Yes, sir.
A bar BC. Then A B bar C.
A B bar C
Then A B C
plus
bar.
A B C bar plus A B C.
Yeah, A B C. So what is the minimal expression for this one? So which one is constant here?
C. A bar B plus A B bar into C
A bar B plus A B bar into C.
plus A
A.
B into C bar plus C.
Yeah, so it becomes
A
XR of
XOR
B
B
into
plus AB.
C plus AB. So this one is also one of the reduced expression. So here for this also we are taking another form. So the another form is like this. So if I take Yes.
సార్ మీ వాయిస్ బ్రేక్ అవుతుంది సార్.
ఎస్ సార్. ఇప్పుడు దాకా చెప్పింది వినపడలేదు సార్.
Hello. Ma, is it okay, ma?
ఎస్ సార్.
Yeah, thank you.
ఎస్ సార్.
Yeah. So can I write this expression for like this? So what is the value of ABC plus ABC plus ABC?
ఏబిసి.
Yeah, ABC only. So here I'm writing like this. So I'm adding two more ABCs. So I'm adding two more ABCs. So if we're adding like this, so this expression will be changed or not changed?
నాట్ చేంజ్ సార్.
Yeah, so not changed. So for this, so here BC is constant. We are taking BC as common term, and for this AC is common. B plus B bar, and for this AB is common. So C plus
సి
C
ప్లస్
bar.
సి బార్.
So it becomes AB plus
బీసీ.
BC plus CA, right?
ఎస్ సార్.
Yeah. So this is also a reduced expression. So if the option does not consist of this expression, so the option does not consist of this expression. So we are going to this one, Nana. So AB plus BC plus CA. Okay.
ఎస్ సార్.
So if
ఓకే సార్.
so if we're adding like ABC plus ABC, so it will not be affected with the expression, right? Boolean expression. So
sir.
it is not affected. So if we're adding ABC plus ABC, it is not affected. So by adding these variables, so then only we are reducing the expression. The final expression we get AB plus BC plus CA. So this is also one of the correct answer. Okay. If the answer does not consist of like this, so at that time we are going to this option AB plus BC plus CA. So in previous problem also same answer, Nana. So if you are using three variables, so if you are using like these three variables, so here also if you are adding like ABC plus ABC bar plus again A bar BC plus AB bar C plus ABC plus ABC. So there is no problem like if you are adding like this. So is there any problem?
sir.
So there is
No,
no
sir.
problem. So for first
No,
two
sir.
terms, so if you are taking AB is constant term. So we are getting AB into C plus C bar, and then here the BC is constant. So if I are taking BC for this and this one, we are getting A plus A bar, right? Yeah, then again you are taking AC, so at the time we get B plus B bar. So the final answer is AB plus BC plus CA
CA.
only. Okay, is it okay, ma?
Yes, sir.
Yeah, so this one is also one of the reduced expression for the given expression or the given problem. So for this problem, what is the reduced expression, Anna? For this problem? So it consists of
AB plus
it consists of
BC
two
plus
solutions.
CA.
It consists of two solutions. So they are AB plus BC plus CA. So this one is first solution, and another
And
solution is
A XOR B into C
A
plus
XR
AB.
of B
B
into
into C.
so these two are the solutions of given problem. Okay, Nama?
Yes, sir.
Yeah, can I move to next problem?
Okay, sir.
Yes,
Yeah.
sir.
So next problem is nothing but so next problem. So it is given in IES 2010, Anna. IES 2010 exam. So if the circuit will be like this, so the circuit will act as which device? The circuit will act as which device? So please, if you are applying, the input will be like this. So if you are applying 0, so what is the output of this first NOT gate? What is the output of
1.
this first? Yeah, 1. This 1 is applied to another NOT gate, right?
Yes, sir.
Yeah,
0.
so the final output is 0. So similarly, if you're taking 1 as input, so what is the output of this NOT gate? 0.
0
And this one is
and
1.
1.
So how many times the value will be changed? 0 is changed to 1 and 1 is changed to 0. So 2 times, right?
Yes, sir.
Yes, sir.
Yeah, here also 1 is changed to 0 and 0 is changed to 1. So here also 2 changes are there.
2 times.
Yeah, so based on this diagram, it is nothing but bistable multivibrator. Bistable multivibrator. So bi, what is the meaning of bi, Nana?
2.
Yeah, 2. So 2. So that's why we are taking bistable multivibrator. So vibrations, Nana. So 0, 1, 0, 1. So like vibration మీకు ఎలా వస్తుంది ఒకసారి ఆలోచించుకోండి. ఒకసారి ఆన్ ఒకసారి ఆఫ్, ఒకసారి ఆన్ ఒకసారి ఆఫ్, అలానే కదా మా వైబ్రేషన్ వస్తుంది, కంటిన్యూగా అయితే రాదు
Yes.
కదా. So like this,
Yes,
so
sir.
2 times, so 2 times it will be vibrate 2 times. So that's why we are taking this device as bistable multivibrator. So if I'm taking
Sir, again your voice are breaking, sir.
I'm getting some disturbances, ma. Internet problem.
Okay, sir. Now it
Okay,
is okay, sir.
okay, ma. Thank you, ma. So how many changes are there? So 0 is changed to 1 with 1 time only, right?
Yes, sir.
Yeah, 1 is changed to 0. So the here also 1 change is there. So 1 is nothing but mono. Mono is nothing but 1, right? The meaning of mono is nothing but 1, right?
Yes, sir.
So that's why this device is nothing but monostable multi-vibrator. Monostable multi-vibrator. Is it okay, ma?
Yes, sir.
Yes.
Yeah. So next problem. Next problem is so like this. Yeah. So this is nothing but so this device is called as
Tristable multivibrator.
so okay, simply it is nothing but square wave generator, Nana. So it is nothing but a square wave generator. So it is nothing but square wave generator. So why it is called as square wave generator? First thing. So why it is called as square wave generator? So on off in the sense of for giving 0, so it is here we are getting 1 and then 0 and then 1, right?
Yes, sir.
Yes, sir.
Yeah. So if I'm taking like this, so if I'm taking first one is 0, then what is the output of first NOT gate, Nana? What is the output of first NOT gate?
1.
1.
Yeah. So it goes to high. So it goes to high position, right?
Yes.
Yes,
So
sir.
up to certain level, yeah, up to certain level, and then again we are applying another NOT gate, and it goes to low.
0.
Yeah, and then
Zeros.
yeah, so 0, 1, 0, 1. So 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 like this only, right? 0, 1, 0, 1. Okay.
Yes.
So I'm not taking this one. So I'm not taking this one. 0, 1, 0, 1. So 0, 1, 0, 1. So like it is in the form of square wave, right?
Yes,
Yes.
sir.
So that's why this device is called as square wave generator. Is it okay? Clear? So how it is called as square wave generator?
Yes, sir.
It's called as a square. So simply it is nothing but square wave generator. So if we are using more than two NOT gates in a device, so if we are using more than two NOT gates in a device, this is called as square wave generator. Is it okay, Nana?
Yes, sir.
Yeah. So for this devices also, so one more problem is there. So how much time period is taken for this technique? So the time period capital T is nothing but 2 into capital N into small TPD. So for finding total time period of the device is calculated by using this formula. Here capital T is nothing but time period and N is nothing but number of NOT gates. N is nothing but number of NOT gates and TPD is nothing but time delay. Okay, ma? Hello?
Yes, sir.
Yeah, so please take a problem. The following circuit, the propagation delay of the propagation delay of each NOT gate is in a following circuit. So in a following circuit, the propagation delay of each NOT gate is 100 picoseconds. Each NOT gate is 100 picoseconds. Then find frequency of the square wave generator. Then find so frequency of the square wave generator. The figure will be like this. Here, how many NOT gates are used, Nana? How many NOT gates are given?
5.
Yeah, that is
5.
nothing but capital N, right? Capital N equal to 5.
Yes.
Then what about TPD, Nana? TPD is equal to 100 picoseconds, right?
Yes,
Yeah.
sir.
Time delay. So time delay or propagation delay both are equal. So here the propagation delay is nothing but 100 picoseconds. Then what about total time, Nana? Total time equal to 2n into
2n
TPD.
into TPD.
Yeah, 2 into 5 into 100 picoseconds. So 2 into 5, 10, 10 into 1000 and then, sorry, 10 into 100.
1000.
Yeah, so the time period is 1000 pico seconds. Here the question is find the frequency of square wave generator. So it is nothing but square wave generator, right?
Yes, sir.
So this one is square wave generator. So here the question is find the frequency of square wave generator. So what is the formula for frequency, Nana? F equal to
1 by T.
1 by T. Here T is nothing but
1000.
1000 pico in the sense of
10 power minus
pico is nothing but 10 power minus 12, Nana.
minus 12. Yes.
So 1 by 1000 into 10 power minus 12. So 10 power 12 by 10 cube. So 10 power 12 minus 3 equal to 10 power 9. So 10 power 9 in the sense of
Nano.
gigahertz. 1 gigahertz. 10 power 9 in the sense of giga. 10 power 6 is nothing but mega. 10 power minus 9 is nothing but nano. 10 power minus 10 power minus 3 is nothing but mini. 10 power minus 6 is nothing but micro. Okay?
Yes, sir.
Yeah. Then coming to next problem. Next problem consists of, so please take a problem. The circuit shown in the figure, the circuit shown in the figure, the circuit shown in the figure, comma, the propagation delay of each NOT gate is, the propagation NOT gate is 2 nanoseconds. The propagation delay of each NOT gate is 2 nanoseconds. Then find the time period of square wave generator. So like this. So the circuit as shown in figure, comma, the propagation delay of each NOT gate is, the propagation delay of each NOT gate is 2 nanoseconds. And then find total time period of the square wave. So what's the value here we are getting? So how many NOT gates are there?
N equals to 4.
Okay, then so 2 into 4 into 2, so totally 16.
Yes, sir.
So it's purely wrong answer, ma. So for giving, this output is given to again for this first NOT gate, right? So the
Yes,
third,
sir.
yeah. So one is given to here. So that's why. So it is nothing but a square wave generator. So in the square wave generator, this NOT gate is not included. Okay.
Yes, sir.
Yeah. So that's why for the following figure, how many NOT gates are used for generating square wave? 3 NOT
3.
gates are, yeah, 3 NOT gates. So that's why capital N is equal to 3 here, and capital T is equal to 2 into 3 into 2 nanoseconds. And the final answer is 12 nanoseconds. Is it okay, ma?
Yes, sir.
Yeah. So please observe output and input terminals here. Observe output and input terminals here. So in previous problem, the final output is given to the first NOT gate. Yeah, the fifth NOT gate output. The fifth NOT gate output here. The fifth NOT gate output is given to the first one. So that's why here we are including 5 NOT gates. But coming to this question, it consists of only 3 NOT gates, right?
Yes, sir.
So that's why in the square wave generator we are using only 3 NOT gates. So please don't include this one. So it is not included in the square wave generator. So totally the answer is 12 pico.
12
So that,
nanoseconds.
oh yeah, 12 nanoseconds. Super. Then yeah. So next problem. So what is the output of following figure? So here the inputs are A, B, and then we are taking 1, 1, 1, 1. So these two are given to one OR gate, one OR gate. So and then we are applying one NOT gate. So what is the output of this one, Anna? What is the output of this one?
AB plus 1 into whole bar.
AB. So here we are getting 1, right?
Yes, sir.
Yes,
The
sir.
output of target is 1 plus AB. And then your answer is 1 plus AB whole
Whole bar.
bar.
Whole bar.
Yeah, but my answer is 0. Why? Because of according to the Boolean laws, 1 plus x is nothing but 1 only, right?
Yes, sir.
Yes,
Here
sir.
here 1 plus AB. 1 plus AB is nothing but 1. 1 is given to this NOT gate. What is the answer we are getting?
0.
0.
So like this we are getting 0. Okay, ma? So please don't confuse. So option is also there, Nana. So the first option is 0. Then second option is 1. Third option is 1 plus AB. Then fourth option is 1 plus AB whole bar. So which one is the correct answer?
First one.
Yeah, first one is the correct answer. So blind గా మీరు ఈ ఫోర్త్ దానికి వెళ్ళిపోతారమ్మా. ఓకేనా? సో ఇట్ ఈస్ ఆల్సో 2015లో ఇచ్చాను నా ఐఏఎస్ ఎగ్జామ్లో. సో ఈ క్వశ్చన్ 2015లో ఇచ్చారు. సో బ్లైండ్గా అయితే వెళ్ళమాకండి, బూలియన్ లాస్ని యూజ్ చేయండి. సో వాట్స్ ద ఆన్సర్ హియర్?
0.
0, sir.
Yeah, 0. In case if you are taking same circuit with the inputs are here 0 0, so what is the value? So what is the output here?
AB bar.
AB whole bar. Yeah, correct answer, mama. AB whole bar. So this one is correct answer. Okay.
Yes, sir.
Yeah, super. So next one. So next problem. A XOR of A is nothing but. So are you know these expressions? A XOR of A. A XOR of A. So please assume A equal to 0, Nana. Assume A equal to 0. 0 XOR of 0.
0.
0 only. A XOR of A.
A.
A or 0. A XOR of A. So here the inputs are same. The outputs are same. What is the value of 0 XOR of 1? 0 XOR of 1.
1, sir.
1. 1 XOR of 0.
1, sir.
1. 0 XOR of 0.
0.
0.
0. 1 XOR of 1.
0.
0.
0. So 1 is one input, another one is another input. So for equal inputs, the output is 0. Here A is one input, another A is also another input. So here inputs are equal or not?
Yes, sir. Equal, sir. So
So
0.
A XOR of A is nothing but
0.
0. Then similarly B XOR of B.
0.
So if I'm taking like this, A XOR of A is nothing but 0. Then simply A XOR of A bar. A XOR of A bar, Nana. A XOR of A bar.
1.
Yeah,
1,
1
sir.
super. A XOR of 0, Nana. A XOR of 0.
1.
A only. A only.
Yes, sir.
A XOR of 1. A XOR of A is nothing but A. A XOR of A bar is nothing but 1. A XOR of 0 is nothing but A. A XOR of 1.
0.
1.
ఇంకా ఏ బార్. సో ప్రూఫ్ చెప్పానా ఏ బార్ ఎలా అవుతుందని?
Yes, sir.
Yeah. So if you are taking XR, so one input is A. So we don't know this input, right? So simply
Yes, sir.
we are taking this one as inverter. So this one as inverter. సో 1 ఇచ్చారు అనుకున్నానా, లైక్ ఇక్కడ మీరు 1 ఇచ్చారు అని అనుకోండి. ఏ వాల్యూలో 1 ఇచ్చినప్పుడు ఏమవుతుందమ్మా? అది ఏ వాల్యూలో 1 ఇస్తే అవుట్పుట్ ఏమవుతుంది? ఓకే, ఇక్కడ కూడా 1 ఇచ్చారమ్మా.
0 అవుతుంది
సో
సార్.
అది 0 అవుతుంది. ఇన్ కేస్ ఏ ఈక్వల్ టు 0 అయితే
1.
1. సో దిస్ కేస్ ఇన్వర్టర్, for this inverter, this one is 1. So if you are giving 0, what is the output here?
1.
మీరు ఒక ఇన్పుట్ని 1 అనుకోండి, డైరెక్ట్గా ఒక ఇన్పుట్ ఇస్ ఆల్వేస్ 1. సో దిస్ ఇన్పుట్ ఈస్ ఆల్వేస్ 1. సో దిస్ ఇన్పుట్ ఈస్ ఆల్వేస్ 1. So if I using like this, so a one input is a, so here we are getting a XR of 1, right?
Yes, sir.
Yeah. So if you are assuming a equal to 0, so if you are assuming a equal to 0, we are getting
1.
1.
Yeah, 1. If you are assuming a equal to 1,
0.
0 అంటే ఏకి ఏమైతుందమ్మా అవుట్పుట్? మీకు ఏ 0 అనుకుంటే అవుట్పుట్ ఏమైంది?
1, sir.
1 అవుతుందని అంటే అప్పుడు ఏ బారే కదా అవుతా ఉంది అది. ఇక్కడ మీరు ఏ ఈక్వల్ టు 0 అనుకుంటే ఇక్కడ మీకు 1 అయిందంటే అది ఏ బారే కదా అవుతా ఉంది.
Yes, sir.
అలానే ఇక్కడ ఏ ఈక్వల్ టు 1 అనుకోండి, మీరు ఈ గేట్కి అప్లై చేసి ఏమైందన్న అది 1 కాస్త
0.
అప్పుడు 0 అవుతుందంటే ఏ 1 అయితే ఏ బార్ ఏమవుతుంది?
0, sir.
0నే కదా. అప్పుడు ఏ XR of 1 is nothing but ఏ బార్ సరిపోతుందా అకార్డింగ్ టు దిస్ డయాగ్రామ్?
Yes, sir.
ఓకేనమ్మా?
Yes, sir.
ఓకే. ఓకే. సో
రిపీట్ చేయండి సార్ ఒకసారి.
ఓకే. So here this XR gate is used for inverter. So how many inputs are there for XR gate, Nana?
2.
Two inputs ఉంటాయి కదా, 2 inputs అయితే ఉంటాయి కదా XR gate కి. యా, నేనేమనుకుంటానంటే వినిపిస్తుందా అమ్మా?
Yes, sir.
Yes, sir.
One input is always 1, Nana. So this input is always 1. So this input, if you are assuming, so this input is always 1. So ఈ బ్లాక్ లైన్ అనేది ఆల్వేస్ 1 అనుకొని ఈ గ్రీన్ లైన్ ఏ అనుకుందాం మనం. సో హియర్ we are getting the expression called as 1 XR of A, right? అంతేనా వచ్చే అవుట్పుట్ XR గేట్ కి?
Yes, sir.
1 XR of A. సో నేనేమంటానంటే ఏ ప్లేస్లో మీరు 0ని పంపించండి. ఇన్ కేస్ ఇఫ్ ఏ ఈక్వల్ టు 0, సో ఇట్ బికమ్స్ 0 XR of 1, రైట్?
Yes, sir.
అప్పుడు ఏమవుతుందన్న 0 XR of 1 అయితే
1, sir.
1.
1. మీరు ఇచ్చిన ఇన్పుట్ ఏంటన్నా? ఏ వాల్యూ?
0, sir.
మీకు వచ్చిన అవుట్పుట్ ఏంటి?
1.
అంటే అది ఏ బార్ అయిందమ్మా? ఏ బార్ అయిందమ్మా? ఏ ఈక్వల్ టు 0 అయితే 1 వచ్చింది కాబట్టి అది ఏ బారేనా?
Yes, sir.
సో అలానే మీరు ఏ దగ్గర 1 పెట్టండి. సో ఇఫ్ ఏ ఈక్వల్ టు 1, సో ఇదేమవుతుందమ్మా? 1 XR of 1 కదా అవుతుంది.
Yes, sir. 0.
1 XR of 1 అంటే 0నా? సో దీన్ని మనం మళ్ళీ ఏ బార్గా అనుకోవచ్చునా?
Yes, sir.
అప్పుడు ఏమవుతుందమ్మా? ఏ XR of 1 అంటే
A bar.
ఓకేనమ్మా?
Okay,
How is
sir.
it clear? Yeah. So next problem. So based on this XR operation, so these are the applications of XR gate, Nana. So these are the applications of XR gate. So if you are assuming A XR of B equal to C. So if you are assuming, if you are assuming A XR of B is equal to C. So A XR of B equal to C అయితే అప్పుడు ఏ XR of C ఏమవుతుందా? ఏ XR of C. సో బీనే అవుతుంది. B XR of C ఏ అవుతుంది. ఏ XR of B XR of C 0 అవుతుంది. సో ఈ 3 కేసెస్ గుర్తుపెట్టుకోవాలి మీరు. అలానే ఆడ్ నెంబర్ ఆఫ్ XR గేట్స్ యూస్ చేస్తే ఆన్సర్ ఎలా ఉంటుంది, ఈవెన్ నెంబర్ ఆఫ్ XR గేట్స్ యూస్ చేస్తే ఆన్సర్ ఎలా ఉంటుంది. సో మీరు ఇక్కడ ఫర్ ఎగ్జాంపుల్ ఏ ప్లస్ ఏ సారీ ఏ XR of a XR of a XR of a. So how many A's are there? How many A's are there?
4, sir.
Yeah, how many XR operations are there?
3.
Yes, so a XR of a. So what's the value of a XR of a? A XR of
0.
a. A XR of a.
Yes, sir.
0 or a? A XR of a. 0 only.
0,
Here the
sir.
inputs.
0.
0. 0 XR of a.
A bar, sir.
0
A.
XR of a.
A.
A kada.
A,
0
sir.
XR of a.
A, sir.
A XR of a.
0.
0. Super. Okay. Then so for this a XR of a. So what is the value here we are getting? A XR of a.
0, sir.
0. A.
Zero.
A, sir.
So please take a note. So if I using even number, so n XRs unnai, n XR gates unnai. So if n is even, the value is 0, right? 1 2 3 4 4 ఉన్నప్పుడు ఏమైందన్న ఆన్సర్
0.
ఆడ్ అయినప్పుడునా
A, sir.
సో ఏ అంతేనా కదా?
Yes, sir.
Yes, sir.
Is it clear?
Yes, sir.
సో 4 XR గేట్స్ XR గేట్లు ఈవెన్ గా ఉంటే ఎలా ఉంటుంది, ఆడ్ గా ఉంటే ఎలా ఉంటుంది, అర్థమైందమ్మా?
Yes, sir.
Yeah. So one circuit consists of 20 XR gates. One circuit consists of 20 XR gates. Then what is the final output? 20 XR gates.
0.
A.
0. Yeah. Super nana, super. Yeah, answer correct. Answer ఏ కరెక్ట్ అమ్మా. 20 ఉన్నాయనంటే అప్పుడు ఏమవుతుంది అది? ఎన్ని XR గేట్లు ఉంటాయి మధ్యలో?
21 A's ఉంటాయి, sir.
కాదమ్మా, 20 ఉన్నాయనంటే మధ్యలో ఎన్ని ఉంటాయి చెప్పండి XR గేట్లో?
19.
19 అనేది ఈవెన్ నెంబర్, ఆడ్ నెంబరా?
Odd, sir.
ఆడ్ నెంబర్ అయితే ఏమైతా ఉంది?
A.
అప్పుడు ఆన్సర్ ఎక్స్ ఉంటే ఒక ఇన్పుట్ ఆన్సర్ ఏమవుతుంది? అదే అవుతుంది కదా, అదే అవుతుంది. 20 XR గేట్స్ యూజ్ చేశారు అనుకున్నాను. 20 XR గేట్స్ యూజ్ చేస్తే XR గేట్లు అప్పుడు ఎన్ని యూజ్ చేయాల్సి వస్తుంది మీరు? ఏ XR ఆఫ్ 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 ఏ అండ్ సో ఆన్ ఏ. ఆ మధ్యలో XR గేట్లు ఎన్ని ఉంటాయి లెక్క అని ఒకసారి? 19 ఉంటాయి. సో అట్ దట్ టైం వీఆర్ గెటింగ్ ఏ. ఒకవేళ ఈవెన్ నెంబర్స్ కానీ యూజ్ చేస్తే అప్పుడు మీకు వచ్చే ఆన్సర్ 0. ఓకేనా?
Okay, sir.
నేను ఆ ప్రాబ్లం చెప్తానమ్మా, నేను మళ్ళీ చెప్తాను మీకు ఎలా వస్తుంది ఏంటి అని. తర్వాత నెక్స్ట్ ప్రాబ్లం వచ్చేసి టు ఇంప్లిమెంట్ XY plus WZ, then find how many 2 input NAND gates are required for this one. So to implement this one, how many 2 input NAND gates are required? So how many 2 input NAND gates are required for this one? So నిన్ననే చెప్పాను ఎన్ని ప్రోడక్ట్స్ ఉన్నాయనా. ఇది ఇట్ ఈస్ ఇన్ ది ఫార్మ్ ఆఫ్ SYP నా XY plus
Yes,
double.
sir.
ఎన్ని AND gates కావాలి, ఎన్ని OR gates కావాలి? 2 AND gates కావద్దా? XY ఒక ప్రోడక్ట్, WZ ఒక ప్రోడక్ట్ కదా.
Yes, sir. 2 AND gates and
2
1
AND
OR
gates
gate.
and 1 OR gate. So how many basic gates are required for this one? 3.
3
How many
NAND gates are
3
required.
NAND gates. So the answer is 3 NAND gates. Then similarly, next problem. So last time gate questions. These all are last time gate questions. Yeah. Next question, Nana. F is equal to sigma m of 0, 1, 5 comma 6 comma 7. So find the reduced expression for this minterms. Find the reduced expression for this minterms. Is it clear, my question?
Yes, sir.
Yes,
Yeah,
sir.
find the reduced expression for the following minterms. What are the minterms here?
0, 1,
1,
5,
5,
6,
6,
7.
7. So this one is A bar, this one is A, and the B bar, C bar, B bar C, B C, B C bar. So if I are taking these two terms, we are getting A bar, C bar.
A bar, B.
Yeah, sorry, A bar, B bar. Yeah, for these two terms,
B bar, C, sir.
yeah, B bar, C. And for these two terms, A, B.
Yep.
A,
Yeah, the solution is A, B plus A bar, B bar plus B bar, C bar. So, okay. So this question is okay. So this one is
Yes,
a
sir.
reduced expression. And then next question. So multiplexer. The question on multiplexers for construction of 4:1 multiplexer. How many 2:1 multiplexers are required for 4:1? So 4:1 in the sense of 4 inputs and 1 output, right?
yes, sir.
Yeah, so the 4/1 multiplexer consists of like this: 1, 2, 3, 4, and 2 selection lines, 1 output. So 4 inputs, 1 output, 2 selection lines. So 2:1 multiplexer is nothing but like this. So 2:1. So this one is one term, and again we are using like this. So 2:1. So these two are given to another 2:1. So finally we are getting 1 output, right? So based on this question, how many multiplexers are required? 3
Two.
multiplexers are required. Three. So this one is one multiplexer, and this one is one multiplexer, and it is also one of the 2:1 multiplexer, right?
Yes, sir.
So following one notation. So here the question is construct 4/1 multiplexer, right?
Yes, sir.
A 4/1 multiplexer with 2/1 multiplexers. So simply you are dividing that 4:1 with 2. So 2 ones, 2 twos. And then anana
Yes, sir.
ప్లస్ అగైన్ 2 మిగులుతుందా లేదా అక్కడ? దాన్ని మళ్ళీ మీరు 2తోనే చేయండి. సో 2 వన్స్. సో అప్పుడు ఏమవుతుంది అన్న? 2 + 1 టోటల్ ఆన్సర్ ఎంతరా?
3.
3. సో లైక్ దిస్. సో దిస్ ఇస్ ద షార్ట్ కట్ మెథడ్ టు ఫైండ్ ది నెంబర్ ఆఫ్ multiplexers. Is it okay?
Yes, sir.
Then similarly, if you want to construct 8/1 multiplexer with 2/1 multiplexers. So how many 2/1 multiplexers are required?
5, sir.
So first we are taking 8/2. So 2 ones are 2 fours plus 4/2. 2 ones, 2 twos plus 2/2. So 1. So total answer is
7.
7. Is it clear, Nana? In the Euro 5 చెప్పారమ్మా.
Okay, sir.
Yeah, then for constructing 16:1 by 2:1. So how many 2:1 multiplexers are required?
15.
So, yeah, 15. Super. And then similarly, 16:1 multiplexer by 4:1 multiplexer. So how many 4:1 multiplexers are required to represent the 16:1 multiplexer?
5.
16/4,
3.
4/4. సో ఇక్కడ ఒక 4, ఇక్కడ ఒక 1, టోటల్లీ 5. ఇస్ ఇట్ క్లియర్ నానా?
ఎస్ సార్.
సో మీరు గుర్తుపెట్టుకోవాల్సింది ఏంటంటే ఫస్ట్ ఏది ఇస్తున్నారు, దేంతో చేయాలి, ఏ మల్టీప్లెక్సర్తో కన్స్ట్రక్ట్ చేయమంటున్నారు. సో హియర్ ద ఫస్ట్ క్వశ్చన్. సో హౌ మెనీ 4x1 multiplexers are required to represent 16x1 multiplexer? So here the question is, how many 4x1 multiplexers are required to represent 16x1 multiplexer? So at that time the answer is
5.
Yeah, 5. Then similarly, so if I want to get 164x1 multiplexer with 4x1 multiplexer. So how many 4x1 multiplexers are required to represent 164x1 multiplexer? So simply we are dividing this 164 with 4. So how many times it will be? Get
41.
64 or 31 amma?
42.
ఏదో చెప్పండి నాకు.
42.
42 into 4 ఏమవుతుందన్న 4 168 అవుతుందమ్మా.
41 సార్.
41. ఓకే. సో 41 టైమ్స్ పోతుంది. మళ్ళీ 41 డివైడెడ్ బై 4తో పోతుందా?
నో సార్.
నో. ఇంకా ఏం చేయాలి? కుదురుతుంది అలాగా?
2/1తో చేయొచ్చా సార్?
దేంతోనూ చేయలేమమ్మా, దాన్ని వదిలేసేయండి. 64/1ని 4/1తో చేయొచ్చాము. చూడండి ఒకసారి, 64/1ని 4/1తో. 64/4 ఎంత నా ఆన్సర్?
21 సార్.
సో 16 4/4. So total answer is 21. So like this we are getting the questions, Nana. Is it okay, ma?
Yes sir.
Yeah. Next question is, how many decoders are required to represent one decoder? For example, if you want to implement 4/16 decoder with 2/4 decoder, ఎన్ని కావాలన్నా 4/16కి 2/4కి? So if you want to implement 4/16 decoder with 2/4 decoders, అప్పుడు ఎన్ని కావాలి? 4/16 decoder ఉందన్న. So decoder consists of n inputs and 2 power n outputs, right? Hello?
Yes sir.
Yes, sir.
Yeah, decoder consists of n inputs and 2 power n outputs. So if you want to realize 4/16 decoder with 2/4 decoder, so how many decoders are required? చెప్పండి. సేమ్ లాజిక్.
2 decoders.
2 decoders, ఒక 2. ఓకే. ఇంకా సో ఫస్ట్ ఒక్కసారి ఆలోచించండి. ఇలా తీసుకున్నారనుకోండి మీరు. సో 2 ఇన్పుట్స్, డీకోడర్కి 4 అవుట్పుట్స్ వస్తున్నాయంట. ఓకేనా నాన్న? సో ఒకటి ఏ అనుకోండి, ఇంకోటి బి అనుకోండి. సో ఇక్కడ మీకు 4 అవుట్పుట్స్ వస్తున్నాయి, 1 2 3 4. బట్ యువర్ క్వశ్చన్ ఈస్ 4/16 డీకోడర్. 4/16 అంటే ఇన్పుట్స్ ఎన్ని ఉండాలి నాన్న? ఎన్ని ఇన్పుట్స్ ఉండాలి 4/16 అంటే?
4.
4 ఇన్పుట్స్ ఉండాలి. సో కాబట్టి ఈ 4 ఇన్పుట్స్ని డీకోడర్కి ఇవ్వండి మళ్ళీ మీరు. సో డీకోడర్లో ఎనేబుల్ పిన్ ఉంటుందా? గుర్తుందా మీకు డీకోడర్కి? ఇప్పుడు ఎన్ని లైన్స్ వచ్చే అవుట్పుట్గా ఒకసారి చూడండి. సో ఇఫ్ ఆర్ యూసింగ్ లైక్ 2/4, ఇక్కడ కూడా 2/4. సో 2/4, 2/4, 2/4. ఎన్ని 2/4 యూస్ చేస్తే 16 అవుట్పుట్స్ బయట వస్తాయమ్మా?
5.
5. సో దీన్ని కూడా మీరు రివర్స్ చేసుకోవచ్చు కావాలంటే. సో 16/4 ఎంత నాన్న? Totally 5. Okay na? Based on the output terminals. So here we are calculating based on the output terminals. Is it okay?
Yes, sir.
For 8/256 decoder, for 8/256 decoder, how many 4/16 decoders are required? ఏం చేయాలి మీరు? 256ని దేంతో డివైడ్ చేయాలి? 16తో. సో 16తో డివైడ్ చేసి ఏమొస్తుందమ్మా? ఎన్నిసార్లు పోతుంది? 16 into 16?
16. Yes, sir.
సో 16 టైమ్స్ పోతుంది.
17.
16/16. సో టోటల్ వాల్యూ ఎంత నాన్న? 17 డికోడర్స్
17.
కావాలి. సో ఇలా చేసుకోవచ్చు. 6/64 అయితే విత్ 2/4 డికోడర్స్ ఇది కుదురుతుందా? 6/64. సో 6 ఇన్పుట్స్ ఉంటే అవుట్పుట్స్ ఎన్ని వస్తాయి? 2/6 అంటే ఎంత? 64ఏనా? 2/6 అంటే
Yes, sir.
2/6 అంటే 64. అసలు 32 అనే నెంబరే రాదు. 32 అనే నెంబరే రాదు. 36 అనే నెంబరే రాదు. ఎలా వస్తుంది? 32 వస్తుంది కదా. 2/5 అంటే 32 కదమ్మా.
Yes, sir.
2/6 అంటే 64. అప్పుడు ఏం చేయాలి మీరు? 64/4 2
2.
4 నాన్న. అవుట్పుట్లు కదా చేయమన్నా నేను. 4 1s 4 16s. 16 again 4 4 1s 4 4s then 4/4. So total number of decoders are 21. Okay? Yeah. Okay ma. So up to combination circuit, you people have any doubts? Hello?
No, sir.
Okay ma. Okay. Thank you ma. You people are